Okay.
Hey everyone, a very good evening and welcome Tamal. How are you?
Hey, Amritans, I'm good. How are you?
Hey, doing really well, really well. So we are back again with the second chapter or second episode, as you like to call it. And as I have mentioned in the first video itself, that the next part that we have to discuss, and which is, I think, according to me, is really important, is pattern recognition. So we should start with pattern recognition, try to understand what is it all about and see can we get some insights that can even help us in understanding how it will connect with the idea of AGI. Okay, so let's look at it and let's have fun. Okay,
Yep.
as people might already know this, that this is basically a second video in this series. Okay, and we have started with this series last month itself. And the first video is out there. So anyone who wants to get a background first, I would really recommend them to watch the first video. And you can find the link and we will find we will paste the links in our description. So feel free to look out there. Okay, all right. Okay, before I get started with pattern recognition, why don't we start with the idea of pattern itself? So if I were to simply say, okay, what is pattern inherently? For that, first, I think the discussion needs to happen, what is randomness inherently? So, Tamal, how do you see what is pattern, what is randomness to you?
Okay. So for me, randomness can be like, say, for example, if I am entering a room and I see all my stuffs are just there, here and there. So that's random. I mean, I don't know where is my stuff, which is what and where it is. So it's just completely random to me. I don't know where is it. And so, and if I enter the same room with, say, for example, all my clothes are in the almirah and all the books are in my shelf and all the utensils are in its proper place in the kitchen. So it looks more organized. So there is a certain pattern to it, and so that looks a pattern. So it's like randomness versus pattern. So this is what I understand when I mean to say random versus pattern, in a very simple terms.
Okay, makes sense. Yeah, that's a very good idea actually. Even I was thinking in the same ways, like if I have to find something from my room and if all the clothes or all of my laundry just spread all across the room, it would be finding like really hard and that would feel like chaotic or random. But once we start imagining this idea that, okay, maybe I have multiple cupboards and I have shelf for, let's say, for my t-shirts, shirts, and let's say trousers, socks, underwear, then finding the next thing or finding whatever I require would actually become incredibly easy. And this is the whole point at the end of the day. And I would like to say, when someone says pattern, basically we can or we should start thinking that they are inherently saying, look, behind this even random looking data, there exists some kind of mathematical function. And that is like the stochastic random assumption that we take for almost all kinds of probability theory and statistics, as a matter of fact. And fundamentally, what it is saying is if you have enough data, and if we can estimate, like just take this example of linear regression that is running right in front of us, and these simulations are basically telling us the same thing, that if you can inherently figure out a linear, you can figure out a hyperplane or a curve, which could fit through the data, then we can make the prediction in future and thus reducing our, thus reducing error and getting a better prediction is that is what we really want at the end of the day. When humans are pretty good with it, even let's say we are not inherently calculating everything all the time, like coming out with frequency tables or probabilities, but we intuitively understand this idea. Like we make a lot of vague decisions based on some partial information and patterns of previous experiences and unrelated contextual knowledge. So you might think about some examples in your real life itself where based on very vague information or very thin information, but because you have so much contextual knowledge within yourself about the world, so many inductive biases already, that would have made you a lot of your decision making actually fairly easy while you are working professionally as well as even operating in day-to-day life. What do you say?
Yeah, we can say we see pattern and we see randomness every day around us everywhere. Say, for example, when you go, I mean, and this randomness versus pattern, this entire thing is the very basics. I mean, the very essence of, you can say, nature, or very essence of being a human. I mean, we humans are very good at understanding stuff. be it a pattern, be it randomness. So the moment we see something which is not fitting our understanding, or we sometimes say that, hey, that is not following any rules, following anything. So, and that is not something which we know. I mean, is it something random, or is it something that we yet to understand? So we come up with these questions when we don't understand something.
Yeah,
So
no, I
be it random, yeah,
totally
yes,
agree with you on this point, as a matter of fact. And I would like to kind of give this example, like with this example that like the simulation that is running. So would you like to talk about this neural network simulation that's running over there?
yes, yeah, that's right. So this neural network simulation, all it does is a complex. It's basically from the MNIST data, you can say. It's just this network is trying to understand the digits. This is, you can say, a digit recognizer. So if it's 7, if it's 2, it's 8. So what a neural network is doing, all the hidden neurons are computing and is trying to see the pattern. Say, for example, 7 is very close to 1. Say 1, I mean, if
Yeah.
that notch in the end at the top. So that and 7 might look same to a network. Okay, so the network trying to understand the subtle differences between a 1 with a notch and a 7. Okay, now once that network understands, then all it does is firing the right neurons, as you can see highlighting. Not all the neurons are highlighting there. So the right neurons are highlighting, and then at the end there is an output 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, and then there the network says it is 7, and the first network it is identifying as 2. So this is how it is. So it's trying to understand the shape. That means it's trying to understand the pattern, the way that 2 is written. It's the way 7 is written, how 7 is different from a 1 with a notch. So this is the network trying to understand, and then it tries to fire those right neurons, and then it's able to produce the right output at the
Yeah,
end.
definitely. And myself being on a more of a computer science side, I also think like anytime when you figure out a pattern, you basically are able to compress information. Like this information that I'm trying to compress, I'm just saying maybe we can have this array, and maybe it might not be perfect, but if I can just simply say, take this array and just multiply it with 4, you get the original array. Almost, maybe only the last yellow one is missing. But see, compressing this information is not going to be easy.
Yes.
If this is inherently random, I cannot really compress this piece of information. And in terms of computer science, as we like to understand all this idea, that basically entropy, so higher the randomness, higher the entropy, okay, at the end of the day.
Yes.
So if you have high entropy, it is hard to compress. Thus, it also means you can think like whenever you deal with a pattern, you deal with a compressed scenario, or you can compress the information. But if you deal with a true randomness, it would be really hard to compress the information. And we can take this example of like what used to happen on DD, let's call it DD National, okay, right now. And before that, news like I'm forgetting, maybe it was 9 p.m. news that we used to get at one point. And before that, they would actually broadcast white noise all across the India. And I used to think they would be resetting something or something, but that was not really the case. They were actually kind of testing their whole bandwidth. And the idea was you cannot really compress white noise at the end of the day. So any image, like the images that is kind of passing, or the videos that are happening through Zoom, a lot of compression will happen at the end of the day. Okay. But white noise is something you will not be able to compress. So it kind of tests your whole bandwidth. But the whole point is, if it is inherently completely random, you do not have any prediction power over there. So you usually want some kind of a pattern, or you are hopeful that at some point there is a pattern in the data, and thus it can reduce your source space. That's one thing that will be really important. And as we will go forward, we will talk about this, reducing the source space kind of effectively. Okay. So at the end of the day, our brain is like doing pattern recognitions almost all the time. Okay, even when we are not realizing, it is doing some kind of pattern recognition. It is trying to figure out what would be the similarity between two people, or what it would be trying to figure out how, let's say, two dogs or two animals are similar, or how some movie that I saw 10 years ago, how is it so similar to the current movie? It happens, right? We watch some movie, I'm like, oh, this is a remake of some other movie. Like I've seen this movie somewhere, right? So this is the whole idea. Pattern recognition is a process of finding regularities and similarities in data using machine learning or variations of deep learning as well. Now, of course, we can do a statistical analysis on historical data, and all we can have some context knowledge ourselves. We might already know something about the world, and based on that, we can actually maybe figure out a pattern. So basically, you can say pattern will represent a regularity in the world or in abstract notion altogether. And Minsky himself came up with this paper where he mentioned in a steps toward artificial intelligence. And this was literally the second point, first one being search. Pattern recognition was the second point he mentioned very clearly and dedicated a lot of, I think, surface area in that paper dedicated to explaining why pattern recognition is so, so important. And I would encourage everyone, we will put the links of this paper. I will encourage everyone to go through this paper. This is definitely one paper you need to read while you are going forward with trying to build an AGI, try to understand what it will take to build an AGI. I think this is something is really, really important. And if great Marvin Minsky has said it, then there is some rationale behind it. And without pattern recognition, the world is chaotic. And if you cannot figure out patterns to shorten your search space, it would be incredibly hard to move forward because we might practically have close to infinite possibilities any given scenario. And you have to cut them down to some feasibles, which one are really feasible at the end of the day. And maybe out of 10,000, maybe I will have 10 or 9 feasible outcomes. And then I will have to make decision based on them only. Or maybe I can match exactly like in a prototype matching that you figure out that, okay, this current object or the current match. So let's say you're trying to do some kind of a bin sorting. So you're trying to figure out, you are trying to put apples in one place, oranges in one place, right? So if a robotic hand is doing this continuously, it needs to figure out which one is orange, which one is apple. We don't want to pack oranges into apples and vice versa, right? So this is important. You have to understand pattern recognition is going to be incredibly important. Whatever way you do, you use your classical machine learning, you go with deep learning. Pattern recognition is here to stay, and very much it's in supervised sense. It has done amazing. I will not say fully solved, but it has done amazing work. And so many of use cases I see in industry, even in academia, I do see they are inherently using supervised pattern recognition at the end of the day. So we'll talk about this, but let's see. And I think I kind of have mentioned what is why pattern recognition is important and how it reduces the search. And always remember, like you can take example here. I will just draw something here. So maybe I can draw some rectangles or squares. So, oh, sorry, I'm using a wrong color here. So at any point you draw a few squares or rectangles and do it randomly. I don't really care. You are very much guaranteed average number of points per rectangle. Okay. But here, that's not really a guarantee. If you have a true randomness, this repeatability will take a hit. You keep drawing random boxes, random squares, or sorry, rectangles. You are not guaranteed. So over there was kind of a uniform distribution. It might look to you as a random function or random data distribution, even in the first one, but I can say there is sense of uniformity. So why? Because you can take any shape. You can maybe even take a circle here. On an average, you can take circles of same size and you will have roughly the same number of data distribution. Here, that's not guaranteed. You can keep doing this over the whole surface area. It won't work. And this is important at some point of time, that if you are trying to do some search and if you can establish that, oh, it looks like there is a uniform distribution behind the scenes, our work becomes really easy, even in statistical analysis, even in machine learning, same with deep learning. Okay. And okay, so Tamal, let me ask you a simple question. So what do we gain from pattern recognition at the end of the day? If pattern recognition works, what do we gain from it?
Yes, this is a very interesting question, and it is a very important question to ask while studying pattern recognition. What is the ultimate outcome of using pattern recognition? Now, for me, and it's in general, pattern recognition enhances the efficiency of the network. Say, for example, I have something totally random. Okay, right. I don't know any structure, anything, nothing. And suppose I take the example of the room that I enter and everything is all over the place, all stuff and all. Do you think I am able to find anything there if I have to find, say, pen or something? I will not be able to find anything there.
Yeah.
Because it is so random and I don't know where is everything. It is all chaos. Okay. Now, if I enter the same room, I know the pens are kept in the table, the books are in the shelf, all my clothes are in the cupboard, everything. So if I have to find a pen, if I have to take a pen, I know I have to go to the table and take it. So that increases my efficiency, the time to solve. For me, having a pen is a task. Now I solve the task very easily because everything was neat and ordered and everything. So that increases my efficiency and also reduces my search space. That is important.
Impressive.
If
Impressive.
if everything is random, the room, the amount of heuristic, the amount of search I have to do will be so high that it will become at a point in time, I'll say that it's not possible, I'll buy something, buy a pen. But if everything is neat and clean, if everything is ordered, that means the efficiency is increasing, that means my search space is has decreased, and I am able to find whatever I'm looking for in the quickest possible time. So that's the essence of pattern recognition.
You can imagine a binary search tree here as well. Like,
yes,
if you can even arrange your data in a binary search tree, basically your effective time in search in a linear search is big O of n. But once you apply, as you might know, it basically becomes log 2 of n. Right.
correct.
And that's a massive advantage. Like, if you can arrange your data even just in a binary search tree. Although we don't want to do it time and again, we definitely want machine to figure this one out. Okay. So this could be an excellent example if we go ahead and think about it. And very well put, actually. Hey, would you like to talk about various kinds of learning that we have in machine learning and how they aid pattern recognition?
Yeah, that's right. This is a very interesting stuff. Unsupervised, supervised, semi-supervised, and self-supervised learning. So all four types of learning that are there are in essence uses some form of pattern recognition, and it aids pattern recognition in the end. Now, supervised learning is like, I am a student, so you are a teacher, I'm a teacher, you are the student. So as you can see from the picture, someone is actually telling you what to do and all everything. So that's supervised learning. There's a set of input, there's a set of output. The network figures out how to get the exact same thing in the output. Semi-supervised learning is, how do we say, small input. There is a small input output pairs, and then there's another set of inputs that a model optimizes and is used for solving. So it's like part supervised, part the model tries to figure out something unsupervised. That's semi-supervised. Unsupervised is completely trying to do on your own. As you can see, the unsupervised example, like you are trying to read your books and there is no teacher to guide you. You are doing everything on your own. That's unsupervised learning. Self-supervised learning is kind of a mixture of all this. So it's a type of it's an unsupervised learning. It follows the criteria that no labels are there. However, instead of finding the right level of clustering, self-supervised learning attempts to still solve the task by traditionally targeted supervised learning. So it uses both supervision, supervised learning as well as unsupervised learning, like image recognition, without any labeling available. So it uses both to understand what the input is and tries to figure out what will be my output. So that's all four types of learning that uses some kind of pattern recognition there to understand the input.
Yeah. So even I would agree with this, and even I think that at one point, like I myself have used a lot of supervised learning. So most of the examples of classical machine learning and even neural networks primarily are like supervised. Like very rarely I have used fully unsupervised, although these days there is a massive push on self-supervised, and people do think that if we crack self-supervised learning, learning new data sets or some completely unseen data set without any annotation would ideally become extremely easy. And I'm really hopeful for the self-supervised, as a matter of fact. And if it works out, this would be some advancement that we are waiting in field of machine learning for quite a while, as a matter of fact. Yeah, definitely. Here are like few examples of pattern recognition for everyone. And again, we have tried to mix up multiple examples for, like, let's say, like SVM and itself, like with linear regression. And then we have iterations, like SVM examples are there already. This one is like a kind of a kernel trick that you can see at the bottom here, where the data is kind of being projected into higher dimension, and then over there it would become easy to separate. And the last example is that card poll example. That is, I think that was in OpenAI Gym, which I think I saw like 5-7 years ago. Interesting example. It's a very simple idea of taking a reinforcement learning agent and you try to train this. So it kind of explores the scenario, tries to balance the card poll in the perfect straight up way. So the idea is it should not ever fall completely. Okay. So, and then we all can imagine the NDOMNESS scenario with various kinds of neural networks. And the idea is how all these neural networks with these nonlinear activation functions see this data or kind of receive this data in numerical format. Some of them are activated to go forward, some of them are not. Okay, just imagine like a brain. Now, let me be very clear with my distinction. Okay, Even when I'm saying deep neural network, I'm by no means claiming that it is very similar to what your brain does. Okay, that discussion will happen one day. And I will make this distinction very, very clear that it's not. It's a very rough mathematical approximation on very basics understanding of Walter Pitts and McCulloch idea of neurons, or how artificial neurons should even be arranged, like firing, not firing threshold. It's a very simple idea that they have come across. It by no means, and whatever neuroscience research is kind of right now saying, by no means current day deep neural networks encompasses the complexity of that. Okay, we will talk about all that, especially in the neuromorphic computing, because that is something that I definitely want to explore furthermore as we go along. And definitely because I just talked about reinforcement learning. So again, I will tell you that yes, in machine learning, you do have this unsupervised and supervised, but there is this reinforcement learning. This is more of like that agent will kind of travel or kind of explore the environment. And then the only issue is environment should be fully mapped. Okay. And as it explores the environment, basically by every step, it should get either some kind of a reward, positive reward, negative reward, and it tries to usually optimize some kind of a function or some kind of a policy gradient. And that has been a core of reinforcement learning. And this core with applying with deep neural networks for pattern recognition has been kind of the backbone of AlphaZero or almost any kind of progress that DeepMind has done in a lot of these stochastic games that they play. And like where they have fixed rules, although they have shown with mu0 that they can, even if someone doesn't tell them the rules, they can kind of very much by a lot of hit and trial. But let me be very clear, there's a lot of hit and trial in reinforcement learning. There is a very funny comparison that we cannot just think reinforcement learning as a one-shot solution. You will not, like, while you are training yourself to drive a car, you do not hit a tree 10,000 times to figure out, oh, hitting a tree is really bad. Okay, we should not do that. Reinforcement learning will take a long time to train itself. So do not be fooled by the specs or kind of the performance measurement that DeepMind and other companies like OpenAI is publishing again and again. You have to understand, they are running on practically on clusters of supercomputers, not just one supercomputer, clusters of them. And whatever they claim in a week, you have to understand this could mean 20,000 human years. If no human is, of course, going to survive 20,000 human years, but I am pretty sure for most of the skills that we acquire, we do not, any human does not take 20,000 years. Okay, we will acquire that in very much in a very less amount of time. Let's say even if you're trying to learn how to play chess or to drive a car, even if I start with a baby, maybe baby will make a more mistake. So maybe we will give them those small cars which are in the malls and everything, but we will still let them drive. Okay, babies will crash the car more, but they will still not take that much time what a computer does. Although someone can say, okay, even if it is a baby, there are some inductive biases. It does understand physics and the world idea of solid and something that you can pass through, right? Machines have zero understanding. I totally agree with it. At some point, when we'll discuss world models, we'll talk about this actually, that we should put some kind of inductive biases. And even when you design a very customized network, that is kind of putting in inductive biases anyways, that you understand why convolution is a better trick while dealing with images. So let's put convolutional layers. It doesn't that layers or neurons automatically become convolutional. That never happens, right? Still, it is done by us. So yeah, that is always a scenario. So Tamal, like what we do, like how do we do pattern recognition exactly?
Yes. There are three techniques in pattern recognition and machine learning model techniques. So first is statistical pattern recognition, next is syntactic, and the last one is neural pattern recognition. Now, statistical pattern recognition is like the pattern model involves historical analysis, statistical data that learns from examples. The model collects observation, process them, and then apply the same rules that it has learned from the data and apply to the new observation. This is a typical machine learning process. Now we train our model on a historical data, and then when some new data comes, we use the same model on that and make our predictions. So that means you are using the rules that we learned in the old data and using that in the new data.
Of course.
Next is syntactic pattern recognition. Now, this is not a structural pattern recognition because it depends on less complex sub-patterns called primitives. Now, words, for example, fall into this category. Now, the pattern described as connection between primitives. For example, words connect to form sentences and text. So this is typical natural language processing. So there, they are the algorithms trying to understand the pattern. They are word vectors, TF-IDF, arm frequency, inverse document frequency. So all various kinds of stuff that machine does. I mean, the algorithm uses to form the sentences, like GPT-3, BERT, and all. So uses this kind of pattern recognition techniques to form the sentences. Next is neural pattern recognition. This is using artificial neural networks. This is like you are using parallel computing, distributed computing, and using high-end, say, convolutional neural networks or LSTM, RNN, and everything. So, and you are trying to understand the input-output relations, the nonlinear input-output relations, the complex, which the simple machine learning algorithms cannot pick. Now, for those kind of situations, you will use the high-end neural networks, which will fall under the category of neural pattern recognition. Yeah, so these are the broadly the three kinds of we use every day, in our task. Yes, so these are the techniques. Now, techniques in pattern recognition. So this by no means is an exhaustive list. This is some of the algorithms that are most commonly used here. Common models and common algorithms that are being used every day, like, so for example, classification, regression, discriminant analysis we use, support vector machines, linear regression, neural networks we use, decision trees, yes, unsupervised learning, clustering, and then there are parametric techniques, then there are non-parametric techniques. Now, non-parametric technique will use autocorrelation, and parametric techniques will use correlations and all. So these are the broad list of techniques in pattern recognition. You can go through them, like which you use. And all methods uses some form of pattern recognition to from input to output to map the input to output.
Exactly. Now, plus we are not really going through algorithm. This is not the means for doing that. Of course, someone will have to create a complete video series for that. So we are not really looking into algorithms. We are assuming that you are familiar with most of these techniques. If not, you will have to kind of get yourself to speed to understand what are different kind of pattern recognition. So by no means we are going to start covering pattern recognition all of a sudden.
That's right. Yeah, that's right. Yeah. So this is more like to give you an intuitive understanding of the techniques that are in pattern recognition. If you want to go through them, you can go through them separately. There are lots of series out there, but yeah. So this is what we are trying to do.
Yeah, wonderful, wonderful. So again, I think I have been talking about this for quite some time, and again, I'm gonna say this, and again, like think about human fingerprints, zebra crossing. You can think about current flows in the oceans, as a matter of fact, and any kind of even arrangement of the rosebud. Okay, so there are like inherently a lot of like infinite patterns around us. Okay, and plus we are collecting more and more data every day, and like this, I think it has went to scales of exabytes already. Okay, so once you have that much data, it's not going to be that easy, and your search space increases kind of exponentially. Okay, usually it kind of increases exponentially. So unless we do not cut down that search space properly, and that's important, and pattern recognition helps us in that. It kind of shows us what is viable or what is feasible, or where you have a high probability of succeeding. Even let's say that where you have high probability of succeeding, follow those paths. And thus, once you figure out the right path, then the search becomes easy. And then your probability of success is going to be much, much easier. And of course, you can help. It definitely helps us with unseen data. That is the whole point at the end of the day. And once you can solve the problems with unseen data with a good level of generalization, this is important, good level of generalization. And in the next video, we are going to talk about this, what is generalization capability and why it is so important. And then thus that will aid us in making kind of practical, actionable suggestions or decisions, which humans can apply in their real world, as a matter of fact. Okay, so that is something that we have been talking, and I would not just directly, but we will talk about this example. Okay, so Tamal kind of found this example, and this is really nice. And I think I have seen something like this on Facebook, and I think it goes like I couldn't believe that I could actually understand what I was reading. Using the incredible power of human mind, according to research at Cambridge University, it doesn't matter in what order the words the words are, and only important thing is that the first and the last letters be in the right place. Okay, the rest can be total like gibberish, and you can still read it without a problem. This is because a human mind does not read every letter by itself. Okay, but a word as a whole. Amazing, huh? Yeah, and always thought like kind of like spelling is so important, and of course like you tell your friends to do this, but just think it like on an average day, if you read this, and even I have noticed like why you do speed reading. So once you have read it, or like people after MBA classes, they will know this actually, because in MBA you have to do a lot of case studies, and they develop speed reading. Anyone who has to do like a lot of reading after a while, they start doing speed reading. Even for a lot of research papers, even I do even for quite a lot of books, as a matter of fact, I do not have to read every line, every word. That's really not required for me. I very well understand what's going to happen. Maybe somewhere, maybe something is there, but rest of it, my brain can very easily simulate and kind of start making a prediction what is going to happen in the future. And this is something that is really interesting. And this shows like how with very less vague information, and because your brain is always simulating well in advance, it is able to make that prediction. So this is impressive, and of course, we can be fooled by this. I'm not saying that it can't happen. This can also lead to some fallacies that we would not want usually them to happen, but it shows incredible power of brain. Like even brain is slower because it's fundamentally biological. It's not going to be as fast as silicon chips. Okay. Inherently, still, it is able to do pattern recognition at a scale that is just mind blowing. And computers would have a massive problem. I don't think so. Any state of the art model will be able to solve this right now. Okay, and this is impressive. The more and more you think about it, it is extremely impressive. But of course, it requires a lot of contextual knowledge. It will not work with a child who has just barely
Yes.
learned English language. It will not work on them. It
Correct.
works on us because we have read a lot, we have seen a lot of books, and we know like which word usually comes after the other. So that contextual knowledge thing is kind of helping us
Yes.
like figuring this out. What should be the next word? Even if I am not able to read the whole thing properly, I'm able to kind of very much figure what is going to happen.
Yeah.
And this is like one interesting and I think an amazing
Yeah.
example while going forward.
Yeah. This is where the importance of pattern recognition comes into play. Our brain does it so effortlessly, we will not know what's going on. But that same thing, what brain does so effortlessly, the brain uses some form of calculation it in milliseconds or even less, and it will tell you what that is. But the same thing, if you give a machine, it will not be able to do. So that
Yeah,
means
yeah,
that machine has not figured out that those patterns, those links, as I said in the syntactical pattern recognition. So those things is important to understand the
yeah,
context.
yeah.
Yeah.
I agree with you. I agree with you. And again, as we already talked about the same example, and as you can see, and anything when we are developing cognitive, or anyways, like if we scramble the words randomly, we can very easily kind of go ahead and we will not have to search every iteration, that we very well know what usually comes after which word, and we are able to make these predictions and understand once patterns are established, like from some examples, from some kind of a supervision or something like that. Classification or like figuring out what will come next becomes incredibly easy, and thus increasing our speed and efficiency. And this is what we are really looking for. But this is the whole point. We humans can do it, but we this is the whole thing. We cannot explain this how we can do it. And this is, I think, one of the search that I'm on, like looking like how our brain is. Maybe we come up with a mathematical model which could roughly or loosely approximate this process. Okay, so this is something that is really interesting, and but the whole point is, where are we going with all this? Okay, where are we going with all this? Is just the same point, that at some point think about, let's say we design a human artificial intelligent agent as like a human baby, very least inductive biases. But unless you do not put a really good pattern recognition system or set of pattern recognition system, it would be incredibly hard because the possibilities in the world are endless, and your model will be practically lost. But once it starts to figure out, maybe it can start figuring out association between water, table, and chair. That maybe you sit at a so you go to the table, you sit at the chair, and maybe you take the water from the tumbler, okay, or from the glass. Unless we don't do this, it would be incredibly hard, as a matter of fact, because as I said, there could be large or infinite set of possibilities, and you have to figure out which option you want to really go with. Something, I will not say it is perfect yet, but I think in alpha zero example, I think this was kind of touched for the very first, means like the explanation that came after that, and I saw the Monte Carlo tree search and how some paths were favored and some were not. I think kind of puts a very active scenario over there. Okay, what do you say about this, Taman?
Yes, that's right. Now, let's say maybe, say for example, you have an artificial agent. You give it, you just built it and you let it introduce in a new environment which has trees and everything. So it is your and you his objective you give is to explore the environment, have some food, but stay away from predators.
Right.
Now this is what the agent that this is why what I tell that agent to do. Now it will use explore the wall, exploit the wall. It will go for food. It will go now. It will how it will do it now. How it will do it? He knows that I mean it has to stay away from the predators. Now it will search for those areas which has more green, and it will see that whether it has threats, and it will go there. If it has minimal threat, it will go there, have fun and have it and everything. So that's how it is. Now this is the essence of pattern recognition. Now to understand the world, the agent is new for the baby. It is understanding the world. It is understanding the patterns, like say building and say trees, sun, moon. So baby can't speak the words. Now it will try to use hands and fingers, finger gesture, hand gestures to understand. We as adults will tell him or her that okay, this is building, this is bar, this is that, this is a human being, and this is someone smiling like that. So that's how. So inside the baby's head, all he or she is doing is understanding the patterns in what it is doing, what that particular person is doing, why that bus is that, where it is going, so how is it working. So these patterns is trying to figure it out. Now this is what the essence of pattern recognition. And then agent, if we develop, has to do the same thing basically.
Yeah,
That's when we call
we have to think about lifelong learning. We have to think about, of course, transfer learning from different domains, as a matter of fact. So that will be required. And we will talk about this in next video, that where are we really going with pattern recognition towards AGI. So what really needs to be done from the side of pattern recognition to really be useful or try to kind of evolve into a form of AGI. Okay. Yeah, that's actually, that's where we want to go. And as I was kind of trying to tell you the same idea, that this was kind of made available, I think in Alpha 0 paper or Alpha Go. I'm a little blanking out on this one, but this is the same thing. At any moment, you have some possibilities, and these can be understood as like branches of tree, but only some of them are feasible. You cannot really venture out on all of them, and this cuts down your search space. Rather than having maybe 8 or 10 search spaces at one place, maybe you will have just 1 or 2 feasible ones. And let's say you will go ahead and choose those while going forward. And this is something that's really important. Okay. But anyways, I think we had a really interesting discussion for today.
Yes.
And I thank you all for joining and kind of listening us on this video series. And the major thing that we always have to remember, that we have to remember the big picture. And we will talk about different topics, but still we want to continue with pattern cognition just for one more video. And we would want to talk about how it will play a very major, is kind of a major role in achieving AGI next. Okay. Thank you, Tamal. Thank you so much for your thoughts.
Thank you,
Amrita. And feel free to reach out to us, and we'll see you in the next video. Thank you.
Yeah, we'll see you. Thank you all. See you. Take care. Bye.
Bye-bye.